Algebra 2, this is Mrs. Gums. We are going to cover 9-2 part 2 today, and this is such a fun lesson. This is angles all the way around a circle. So in 9-1 we started talking about triangles, right triangle trigonometry, where we had angles inside of these triangles. And then in 9-2 part 1, we learned that there's a whole other way to measure an angle, not just degrees, but we also have something called a radian. And so we focused on what a radian is and doing conversions. And so now we're going to take a look at these angles and see what happens if we put them on a coordinate plane. And so a coordinate plane, if you remember, is this X and Y axis. And you can see we're now not just thinking about a triangle sort of by itself, we're putting this on a coordinate plane. And so to do this, we have something called a ray, which is a starting point, and then it has an arrow pointing in a direction out there. And the first ray is what we call the initial side. And for it to be in standard position, what we do is we put this initial side ray right on the positive side of the x-axis from the origin. And then what we do is we're going to take a second ray and we're going to rotate it, and in a counterclockwise direction if it's positive, a clockwise direction if it's negative, but we'll talk more about that soon. And then we'll call that the terminal side. So these two rays that are at the origin, when we rotate the terminal side, form an angle on the coordinate plane. And so you can see how these are formed. I'm going to show a couple here where we just take this initial side and it can rotate in what we call the first quadrant, where our x's are positive and our y's are positive, right out here. And so you can see I'm hitting lots of different angles as I move it and rotate it. And I could stop it here, and now I've made a 90-degree angle. I could take another one. I'll show you kind of over here, where I rotate this around and I move through quadrant 1 to 90. 90 is kind of that border between quadrant 1 and quadrant 2. And quadrant 2 is when we're actually going negative as an x value, but positive as a y value. And so you can see I've rotated out this obtuse angle that takes us all the way into quadrant 2. But what's cool about the coordinate plane is that unlike a triangle where the max of degrees or that we could have is 180 inside of a triangle, what we have is this sort of unlimited angle measure that we could have, where I can go to 90, quadrant 2 takes us to 180, which we found out last time was the same thing as pi. And I can move this into quadrant 3, and I can keep going, right? This is 270 degrees. 270 is like 90 plus 90 plus 90, right? So we're moving way beyond the idea of something that could be put into a triangle. And you can see here, this has looped all the way around through quadrant 1, quadrant 2, quadrant 3, or quadrant 4. And I could keep going and now doing a full revolution. Like if I go all the way around, I've gone 360 degrees, just like a circle, right? 360 degrees. And I could actually keep going. I could do 360 degrees and then some more. 360 degrees plus another 360 degrees. And so I can keep going around and around and around and do these revolutions. One other thing is I could take this terminal side, and instead of going counterclockwise to get a positive angle, I could actually go negative. I could actually go clockwise. And so this would be like a negative 45 degrees, for example. So you can see on our notes, like we've really dealt with angles between 0 and 180 before, because those are the sort of restrictions we have within a triangle. But we're going to move this on within a circle and beyond, right? Okay, so I'm going to switch my feature here so I can fill out some of the notes that I hope you've printed out or at least are following along with. And so this is 9-2 part 2. We're going to take this idea of our notes, or take this idea of angles, and we're going to put them around a coordinate plane. And so we started off by saying an initial side is when we fix one ray, and for standard form, it lies on the positive x-axis. And so for us, this coordinate plane, right, a coordinate plane is this thing right here, where we've got an x and a y. And so for our initial side, start at the origin, and I'll put it down here, initial side, on that x-axis. The terminal side, this is what we call the rotated ray. And so this means we've taken the ray from this initial side and we rotate it somehow. So as I rotate it, this side right here becomes the terminal side. And oftentimes we can just put either a theta in here because we recognize that this is the angle that we've created with these two rays. Right? And so for something to be called standard position, it means that we began at the vertex at the origin, right, which is like 0, 0 right here. And just like we said, the initial side is on the positive x-axis. Okay, oh, kind of blurry. There we go. Okay, so how do we draw these angles? This is kind of fun. So 240 degrees. Well, I'm going to have my initial side right about here. Here's my initial side. Let's get this autofocus going. There we go. And so 240 degrees. Well, I know that up to here is 90, plus another 90 is 180. But if I did another 90, that would be 270 degrees. So I don't want to quite go that far. I want to do 180 and then beyond to 240, which is really like, if this is 180 degrees, 240 would be another 60 degrees, right, as we go through. So it's kind of like I need an extra 60 degrees going this way. And now we've got a total of 240 degrees, right, this giant angle here. And you can see it's kind of like 180 plus 60, right? So we can kind of see that this, like right here, kind of like 60 degrees. So 500, well, 500 is really cool because this is beyond 360 degrees, which means we're starting with our initial side and we're rotating a full loop, 360 degrees. But we still have more to go. So if I do 500 degrees and I take away 360 degrees, well, what's left? I have 140 degrees left. So I still have, after I go 360 degrees around, I have 140 left to go. So I know that's another 90, but if I go all the way over to this side, that's 180. So I don't quite want that much. So I need to just go about 50 degrees more, and that gives us approximately our 500 degrees. And you can see that from here to here, that's like 140 degrees. And you see this 360 that went around the first time. So it's 360 plus 140, which gave us that 500. All right, and then part C, we get a negative angle. So here's our initial side. And instead of going counterclockwise, because we know counterclockwise, which is like this way, that's our positive motion. But if we're going negative clockwise, which is this way, that's going to be a negative degree. All right, so negative 50, well, if I go all the way here, that's 90. So I only want to go about negative 50, and right now I'm just kind of estimating. But I know I'm in the right quadrant. So negative, because I went this way, 50 degrees. All right, so we can draw the angles on a coordinate plane in standard position. Remember, standard position means what we just set up here that we start with the vertex at the origin, we have an initial side here, and then we rotate either positive, counterclockwise, or negative this way. Okay, so one thing that maybe you noticed in our last example is that 500 degrees ended our terminal side. If you remember, we talked about what terminal side was, the ending ray. Well, that ending ray actually would be the same as just if I had to graph 140. 140 degrees would have taken me to this same spot. And so what's neat about 140 degrees and 500 degrees is that they're called coterminal, where they actually share the same terminal side. They take different paths to get there. They're technically different angles, but they share the same landing spot. They share the same terminal. And terminal is kind of a word that I think of like an airport, right? Like you're going into a terminal. And in an airport, it's kind of neat. Like I might fly in from Hawaii and you might fly in from Alaska, but we land in the same airport at Metro Detroit and or Metro Airport in Detroit. And we land in the same like terminal, right? So we share the same ending spot, even though our pathways to get there were different. Hawaii or Alaska, different pathways, same terminal. Same thing here, different angles, different paths around as we were rotating, but our terminal side ends in the same spot. So when we take a look at this one, it says we have negative 45 degrees. It wants us to find one positive angle and one negative angle that are coterminal. And remember, coterminal has this terminal, meaning it's going to have the same terminal side as we go around the circle. We'll have the same sort of ending ray. So negative 45, well, let's just graph that so we can see what negative 45 would be. Negative 45 is like halfway, right? Because if this is all the way from the initial side here down this way would be negative 90. So 45 is exactly in the middle of 90. So I'm going to do negative 45 is right there. But what would be another angle that would be positive, right? That would be positive that could take me to that same spot. So that means if I were to sort of just draw this, I would want to go positive and land in that same spot. So what is that positive angle? Well, we know together they should add up to be 360, right? They kind of make this 360. So the way to do this is to take our negative 45 and we're going to add it to 360. And when I do that, I get 315 degrees. So from here all the way around is 315 degrees. And so 315 degrees and negative 45 degrees, well, that's what we call coterminal. Different pathways. One went clockwise, right? Negative 45 went clockwise, and 315 would go counterclockwise all the way around this way, but they land in the same spot. They have the same terminal side. All right, so negative 45 is already negative, but it wants another negative angle that would still land in this same spot. So here's our negative 45 again. So it wants another negative. Well, how could we do that? We could go around once and then go negative again. So what does that mean? That means we went negative 45 degrees and then we went around the circle again in the negative direction. So before I added 360, this time I'm going to subtract 360 degrees. And so when I do that, I get negative 405 degrees. So you can see going all the way around once is 360 plus another 45 in the sort of negative direction gives us negative 405 degrees. Just like that. All right, so why don't you try 395 degrees? You can maybe pause the video, give it a try, and then come back and we can try that one together. Okay, and then if you don't want to try, you don't have to pause and we'll just do it together right now. Okay, so 395 degrees. Well, this means we went around the circle. 365 degrees. And it looks like if I went around the circle 365 degrees, that means I still have 30 degrees to go. So then if I go 30 more degrees, it takes me about here. So 365, or sorry, 300, I'm thinking of days of the year, 360. And so around the circle, so 360 degrees, and that means I have 35 more degrees to go. Well, wait a minute, 35 degrees is positive. So I could just say 35 degrees is coterminal. Instead of just going all the way around and then 35 more degrees, I could just go 35 degrees, and that would be coterminal. So I could just do that, or I could say, just a little bit, or I could say, well, let's do our adding again. I could just say what we had before was 395 degrees plus 360 degrees, and man, that's going to give us a big angle. That's going to be 1,055 degrees, I think. So I could do that too, right? We could do that too. We could say, wow, this is a big angle. And that means we're going around the circle once. We're going around the circle twice, and another 35 degrees. So you could do either one, because both of these, 35 and 1,055 degrees, they're both other positive coterminal angles. And that's the thing, right? Coterminal angles depend on what multiple of 360 degrees is added or subtracted. Right? And that's what coterminal really just means. It's a multiple of how many times did you go around the circle before or after, right, to get that same spot. Okay. Oh, autocorrect. See, sometimes manual focus is still better. We're still a little ahead of the robots. Look at us, we're winning. Okay. So then we're back to this 395, which we said was like around the circle plus another 35. So here we are at 395. This time it wants a negative coterminal. So I'm going to do 395 degrees, and this time I'm going to subtract 360. So when I subtract 360, that gives me 35 degrees. So can 35 degrees be our answer if we want a negative coterminal angle? No, because 35 degrees, even though we subtracted, well, this is still positive. So that doesn't answer our question, right? Like, yeah, we went, you know, we're trying to like undo going around once, but we're still left with a positive angle. So what we have to do is we have to subtract again. So the thing to remember here is that you need to subtract until you get an actual negative angle that you can use for a negative coterminal angle. So if I do 35 degrees and now I subtract this 360 again, now I'll get negative 325 degrees. So now we can see if I go backwards, negative 325 degrees, that would give me a coterminal angle with 395 and 35. All right, so the big idea is you take your angle and you're gonna add 360 to it or subtract 360. Now you might have to do it multiple times, because if it says a positive coterminal angle, you have to make sure that after you've added 360, you still have a positive angle. And the same thing with negative. If you're subtracting 360, make sure you subtract enough times so that you actually do get a negative angle when you're going through it. All right, so radians, coterminal with radians. So we're gonna do the same exact thing. The thing that's a little tricky is that it deals with fractions and we need to get a common denominator sometimes. But it's the same process. So the first thing we have to know is, well, what is 360 degrees in radians? Because before we took our angle and we added 360, or we subtracted 360. This time, instead of 360 degrees, we're going to do 2 pi radians. We talked about our conversion factor last section, right? That pi is the same thing as 180 degrees. So then that means another 180 degrees that gets us to 360, right, is the same thing as 2 pi. 1 pi plus 2 pi. And that's kind of cool. That's why, like, when people say like a circle is really 2 pi, right? Like pi is the angle's only halfway. So when people say like, bring an apple pie, they really mean bring an apple 2 pi, because they don't want you to bring half of a pie, right? They want you to bring like a half of a dessert. They want you to bring the full circle. So an apple 2 pi. Cheesy math joke, there you go. Okay, so how do we do this if we have radians? So I'm going to do the same process, pi over 3 plus, this time I'm going to do plus 2 pi instead of 360. The only thing is I might have to get a common denominator so that when we're adding fractions, we have a common denominator. So that means I'm going to do pi over 3 plus 2 pi. Well, what's the common denominator I'm going to need? Well, I'm going to need a 3. So I'm going to multiply by 3 over 3, so I get a common denominator. So this turns into pi over 3 plus 6 pi over 3. And 6 pi over 3, if I reduce that, that is 2 pi, right? So it's the same number. We've just got a common denominator so that we can calculate this. And now 1 pi over 3 plus 6 pi over 3 is 7 pi over 3. Now, you don't have to graph these. Like, we're expecting you to at least be able to do this, like adding. But just to give you a visual representation of what's going on, pi over 3 is really cool. And we're going to talk more about this in a second. But if we said that this whole thing is pi, well, if I split it into 3, this is pi over 3 means I split pi into 3. 1, 2, 3 parts. So what's 1 pi over 3? Right here. Here's pi over 3. So it's 1 pi over 3. So what's 7 pi over 3? Well, 7 pi over 3 is 1 pi over 3, 2 pi over 3, 3 pi over 3, and 3 pi over 3 equals pi, right? 4 pi over 3, 5 pi over 3, 6 pi over 3, and then 7 pi over 3. So it just means I went around the whole circle plus another pi over 3. Right. You are not expected to know how to graph those. I'm just kind of giving you these charts here. So that, well, I mean, you're going to be expected to know them on the unit circle in a moment. But in terms of the coterminal, you just have to be able to find this value for this type of question. But I'm kind of showing you, like, you know, just the visual representation so you can see what that means. Okay, so the next part needs a negative coterminal. So negative coterminal means I'm going to do pi over 3. Just like before we said negative 45 minus 360. This time we're going to say pi over 3 minus 2 pi. And so minus 2 pi, well, we're going to need a common denominator again. So that's going to be the same thing as pi over 3 minus 6 pi over 3, which means we're going to get negative 5 pi over 3. And so graphing that, if I split pi, remember pi is like half of it. So 1, 2, there's 1, 2, 3 sections of pi. So 1, 2, 3 more sections of pi, right? So negative 5 pi over 3 means 1, 2, 3, 4, 5. Negative 5 pi over 3. Okay, so then we get to 3 pi over 2. So 3 pi over 2, well, if this is pi and halfway, half of, like if this is 0 and this is pi, this right here is half of pi. So we call that pi over 2. So if this is pi, this is halfway. That's why it's pi over 2. So 1 pi over 2, 2 pi over 2. This, right, 1 pi over 2, 2 pi over 2, 3 pi over 2 is right here, down here. And you could do the conversions. Like if you remember 180 degrees, right, we said is the same thing as pi, right? So if I had 90 degrees and I wanted to convert it, well, we would get pi over 2. That's why we have pi over 2 here. Same thing, if I have 270 degrees and multiplied it by 180 degrees, I get 3 pi over 2. So you can kind of see how the conversions work. But also, when we're talking about radians, we're really just like slicing pieces of pie. What fraction of pi do we have? So if I want to find another positive coterminal angle, I'm going to add 2 pi to this. Now this time I'll have 3 pi over 2, and I have to get a common denominator, so times 2 over 2. So that's going to be plus 4 pi over 2. So that's going to turn into 7 pi over 2. So 1, 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, and 7 pi over 2. So that's kind of fun. All right, same idea here. The negative coterminal, 3 pi over 2 minus 2 pi, we got to get a common denominator. Up here, the common denominator we needed to do was times 3 over 3 because there was a 3 on the bottom. This time it's a 2. So I'm going to multiply it by 2 over 2 so that we get 3 pi over 2 minus 4 pi over 2, which is negative pi over 2. So just negative pi over 2 takes us to that same spot that we had before. All right, so this first part, that kind of concludes the first part, the first video of coterminal angles and how to draw an angle on a coordinate plane. And our next video is actually so exciting. This is when we actually get to see what are the degrees all the way around the unit circle and what are the radian measures all around the unit circle. So you can take a look at the second video now. And